processing that mainly focuses on techniques to increase dataset size and diversity. The very first thing, before we move ahead, we need to understand that why this point is so much important in case of your deep learning processes, why we need to enhance data size, or why we need to apply some additional functions or approaches or methods to update info about your data before building a deep learning model. So if we go with the essentials of deep learning very first, there are generally two things on which deep learning. Yes, please.
Make it presentation more, ma'am.
Oh, okay, fine. So there are generally two important things that we need to keep in mind while building a deep learning model, or mainly to ensure quality in your deep learning model. One is how well your neural network, or mainly your deep learning network, is trained, how well it is designed.
Varun, please mute yourself. Varun Saxena.
And the second thing we need to keep in mind is quality and quantity of data. These two factors are the most important. Tuning a CNN model, there are again several hyperparameters. Some of those we have understood yesterday's session also. We have discussed about what we can do to create an in-depth model. We can add multiple layers and then we can update its hyperparameters also. There are plenty of things that we can do. But more than that, there is one more fact, which is data. What kind of data we have in hand that puts a great impact on quality of your model performance. Moreover, in today's scenario, when we are getting like billions of data points from various different settings, that includes applications from healthcare, medicine, or we can have industrial applications, satellite applications, everywhere deep learning is being employed. So we always need to ensure highest performance from deep learning models. That is only way to get satisfactory results if we deploy things in the real time. But if data quality is poor, or if we don't have enough data, and this is a common scenario in most of the areas, like if we talk about patient data, you will rarely find a good quality data from a real hospital, because most of the doctors or patients will not agree to share a data set with you. So we generally find very less amount of data. Same goes with some safe zones, like maybe if you want to get CCTV data, people would not like to share their privacy information with you. Or maybe some data set from vehicles you want to get, that again cause privacy issues. So people are not willing to share data set for train any kind of models. So in those scenarios, whatever information we have, or whatever images, audio, or whatever information we initially have, from there only we may sometimes need to enhance data quality. And in order to do that, there are some specific techniques. As a whole, we call them data augmentation techniques. The idea behind data augmentation is to artificially create new training data. We mainly focus on training data. Sometimes we also add it to validation data, because that is also considered as a part of training data. Test data we generally keep away from this augmentation, that we use in the pure form only. So we are focusing on the training data and its sub-element while working on data augmentation. So the idea is to apply some domain-specific techniques to enhance your data samples in such a manner that we can have better learning or generalization capability on your CNN model or any other deep learning model. So when it is not possible to collect huge amount of data from the filled environment, the second best option is get augmented.
Pile, ma'am. Pile, ma'am.
और वो भी मैं आपको बताऊं Everyone is requested to keep their mics on mute.
Thank you very much. So generally, the primary purpose of applying data augmentation is to increase diversity and variability in your training data, so that whenever a machine learning or deep learning model is exposed to this kind of data, we can reduce the risk of overfitting. We have already discussed that overfitting occurs when your model learns some noise or irrelevant patterns out of training dataset. It may be due to the extra elements present in the data set, like some artifacts etc present in your images. They may also cause some learning of the model, but that may not be a useful learning process, so that leads to overfitting some kind. So data augmentation can help us to reduce that unwanted pattern from your data, but increase the generalizability by improving only the relevant features out of it. And there are so many ways to do this, and this is more important to understand that data augmentation, although we generally talk in terms of image data, but this technique can be actually applied to text, audio, time series data. On a variety of data sets, this data augmentation can be applied. However, most of the time we consider it as a part of image processing. Before we discuss different techniques of data augmentation, let us have a quick idea about its importance. As one thing I discussed, limited data availability, because this is always challenging to get data set from the real field environment, and when you need a model that is robust and can be deployed for the real settings, you definitely need to train it with a good quality data. So data augmentation can be a cost effective way to increase size and diversity of training data, so that you can have more accurate model performance. One more, overfitting we have discussed just now. It is the idea is to provide your model a broad range of scenario by creating some shifts, by creating some different versions of your data, so that it can understand all possibilities related to your field information. Then improved model performance, this is the ultimate outcome you are getting from data augmentation. When we are training some models, maybe you will be getting good accuracy on the training data set, but it may be failing on your validation and testing data set. So in those cases also, as well as for individual training performance as well, in both cases that augmentation is going to be very much useful, because it leads to better feature extraction, as well as it gets very in-depth information from your even when the field data set is very less, because we are creating some virtual shifts in data, that is possible to grab more feature information from there. Then comes class imbalance mitigation. This is another important issue. Class imbalance we have discussed earlier also. In one of the sessions I disclosed one concept about class imbalance. This is when your field data or whatever data set you are using, maybe on CSV side or image side, if there are not equal number of observations in all available classes. Like for instance, you have two classes in your data, dog and cat you want to classify, and there are like 1,000 observations from dog category and only 300 observations from cat category. So that is a kind of imbalanced data set, and these kind of data sets are going to underrepresent certain classes, because your model will not be able to understand cat images so well, but yes, it will be good enough with the dog images due to higher number of availability over there. So in order to deal with such issues, we can have data augmentation. Means from the lower class we can generate new images to meet the level of dog class, so that your model can understand both categories pretty well. It can be also used in case of transfer learning. These are one of the most commonly used options these days by the researchers who are building some new models in the deep learning area. So there are some pre-trained or fine-tuned models that work that are mainly designed on the smaller data set for achieving a specific data set. But if you do augmentation on the target data set, then you can ensure robust representations from there itself, and it will be able to get proper predictions or forecasting on the new tasks that you present to such models. There are two important terms now for the comparison also. Sometimes we also get one more terminology, that is synthetic data set. So many people as a beginner, they just confuse between augmented data and synthetic data, but there are two different terminologies. When we talk about augmented data, it is basically driven from the original data. Means first we at least have some original data, even if it is small in quantity. Then we make some minor changes into that. It may be like flipping, it may be resizing, cropping, brightness, contrast, anything it can be. And based on that, we try to increase the size diversity of the training dataset. However, in case of synthetic dataset, this is mainly produced in the artificial manner by without using any kind of original dataset. Means from the base itself, it is a artificial dataset, and although it is generated for a specific application, it is not like you are getting images from anywhere randomly. It is application based. Like we can design a model maybe from the DNN or generative adversarial networks. We can take help from there and we give them a specific application while building the model, and that generates your images based on that specific detail or keyword that you provide to it. But still, this is not like from the real scenarios. When we search data sets online, maybe if you are looking forward for some research applications or anything you want to develop in future, there are like thousands of sources of data online. If you search different websites, you will get plenty of data sets. But in order to develop a good quality model, always prefer to get real source of data instead of synthetic data, because synthetic data sets are good enough just when you are trying to learn things. And then okay, synthetic data sets will also provide you, but in order to design a robust model, it is always better to have real field data, even if you have augmented it to create your bigger set of data, but still a real data will be more useful. Now let us come to understand this various type of traditional transformations that can be possible to augment your data set. So we start with the geometrical transformations. These are some of the common words that we can use in the day-to-day life also. Simple English language we have over here. Flipping task, you can flip images horizontally or vertically. There can be rotation, we can rotate them by a certain angle. It can be a cropping technique. Based on the region of interest, we can crop certain images to increase the population of sets in our data set. Similarly, scaling also we can do. We can scale them on different levels to get a specific focus on the pictures. Then translation is one of the options, like shifting images horizontally or vertically, that we can do. There are perspective transformations also. They are basically specific to some distortions that we add into the images to understand its robust patterns. So even if your model is getting some noisy data, still it should be able to predict it better. Then it is possible to have some color based transformations also. Second technique for augmentation, second category for augmentation you can have is color based transformations. It can include like brightness adjustments you can apply, maybe increasing or decreasing brightness of your images. Contrast adjustments are also possible. We can have color jittering also, like randomly putting some contrast, saturation, or brightness combinations on your image to get a different look out of that, but with the base idea of the same image. Grayscaling is one simplest approach you can follow for the color based transformations. Two more options we have is noise injection and kernel filters. In noise injection, we can add Gaussian noise into your images or audio signals, and salt and pepper noise also. These two terminologies are most commonly used by people who use image processing or video processing based applications. So They either add salt and pepper noise, minor spots you will observe in an image that is injected with salt and pepper noise. And similarly, Gaussian noise also create little bit fine disturbance in your existing images, so that we can create a robust data quality from there without disturbing the inherent features of your data. Similarly, kernel filters are also there for blurring or sharpening of your images on different sets of pixels. We can apply these filters to blur those pixels, or sometimes to sharpen those pixels to get another level of your data set. So these are some commonly used transformations and how they appear. Let us have a quick idea. Some of these I'll just show you with some examples over here, such as when we are applying a horizontal shift augmentation. So if we have a simple dog image and we just shift it horizontally into different dimensions, you can see that it will be shifted to different positions within your image, on one side, one other side, just by adding some width based shift, or towards right, towards left, we can shift the image based on that. Like from, even from, if we say like this is your base image, from this only all these images we can create. So there can be multiple levels of shift that we can add, and maybe if there are like just 10 images of dog, even from there only we can produce maybe 100 more images by just adding this shift. And the parameter that we add for this purpose is width shift range parameter. While building your model, this particular parameter you can add. Then one more example is vertical shift augmentation. Just another idea behind this we have is, in this case we are shifting it right or left. We also call it positive or negative shift. However, in case of vertical shift augmentation, we are moving pictures vertically up and down with certain dimension factors that we can add into the system. So we precisely call it height shift range argument that we add into the function parameters, and you can see that we are just putting things up and down. But we always need to keep in mind that which technique is suitable on which type of data set. For instance, like for this dog image itself, horizontal shift is somehow tolerable. We can just see that okay, the dog is visible up to some levels, if we are just putting it on the edges or somewhere. But you can see if we are applying vertical shift up to extended level, the image gets cut from certain portions. So we cannot always say that any augmentation technique will work on any data set. That is never possible. We always need to be careful in method selection. We have to choose accurate method that can be applied on a specific type of data. We can also talk about horizontal and vertical flip augmentation. You can see how the image is changing right here. We are flipping it on certain angles. We can say like vertical flip, we can have horizontal flip. But again, the selection we have to do carefully. For instance, when we have photographs of some animals, birds, maybe horizontal shift will make a sense. But vertical flip, it will just turn things upside down. So that will not be so useful. However, vertical and horizontal shift, we can say, just your horizontal flip, we can say, okay, fine, this is to this side, this is to this side. But still, we can just understand that okay, this is dog image. So your CNN model can also understand that, okay, this is the image of a dog. But if it is totally altered, then the meaning may change sometime. However, in other case, when we are getting images from maybe some aerial photographs, or maybe some cosmology photographs or microscopic images, in that cases possibly your vertical shift will also make sense, so we can choose it from there as well. So the selection we have to make carefully. Sometimes what happens that if we apply a wrong augmentation technique on your data and we just build a model over that, it will even make your accuracy poor. So then people say that okay, we just applied augmentation and the model accuracy is getting very poor, so augmentation is not a good technique. But that is not the case. We just need to choose right method. If you choose wrong augmentation method, you put some garbage images into your existing data, your model will not be able to generalize information and it will fail to give you predictions. So the selection is always an important thing. We sometimes do hit and try, like we try 1, 2, 3, we apply 2, 3 augmentations in sequence, then we switch between them, we turn one off, we turn other off, then we see what impact we are getting on the output of your model. There are a few more examples you can see, like random rotation augmentation. Like we are just rotating it by certain angle continuously, and we'll just try to ensure that the actual purpose of the image stays within. So this can be done in the clockwise wise manner, or sometime we do it anti-clockwise manner also. From 0 to 360 degree you can rotate it anyhow, considering that the actual meaning should be preserved. Like for a dog image, this may not be a good choice, but this may work, this may work, this may also, maybe up to some level it will also work. So that we have to decide that how much shifting or how much rotation is good enough. Rescaling also we can do sometime. We can just fix up certain area or certain size of your image that we want to highlight, and based on that we can crop, we can cut, and then we can present your image to the model. Random shift in brightness is also a part of augmentation, and you can see that how many versions of image we can create just by adjusting brightness levels. So this basically helps you to understand different lightning level effect on your images. Like we can consider it more useful when you are working on CCTV images, because CCTV is going to work day and night. So if you are gathering data that is only from the day hours, but your CCTV system or the security system is not able to understand how this will look in the night hours, so better to add some random brightness adjustments in your data, so that we can make it robust enough to understand the movements or the motions around in all brightness conditions, and we can just find intruders easily by that advanced security system. So this is again one important thing we can add while doing augmentation. It is possible to do zoom augmentation also. You can add zoom effect on the zoom in, zoom out, both things you can try. So you can see different versions of image from there we can create, and it can be based on the default value. We can see like it is 1 comma 1, that will not add any zoom effect, but when we update this factor into your model, we can add certain value, and then we can just pixelate values based on the whatever entries we have made into that function. So this is another example of your transformation. Let us talk a little bit about different applications of data augmentation that are the most popular ones where we generally recommend applying this. Healthcare, one of the most popular, because getting medical images with proper labeling and proper information is little time consuming and an expensive task. We mainly need a subject matter expert who can validate your dataset, as well as while performing your various data analysis techniques. Then also you need help from some expert who can just verify if you are using right analysis technique, or if the normalization or scaling technique is accurate or not. So in case if we apply some geometrically proven or transformations that we have discussed earlier, they can easily help you to generate more robust information without hampering the actual details in your picture. Because applying some external methods to enhance your datasets will be a different thing, but augmentation methods, they can always give you proper generalizability from your dataset by following uh, methods, such as we have shifting methods, we have scaling methods. So maybe if we are working on a tumor, so maybe zoom will work. Zoom will work, just we will just be able to enhance that area where tumor is. Similarly, if we are working on maybe some x-ray images, so altering some brightness levels will work over there also. So these decisions we may have to make accordingly. Such as we have one example of pneumonia classification. In this case, we can apply random cropping, zooming, stretching, or color space transformation to enhance model performance. but we definitely need to be careful. If there are some unwanted rotations or reflections that can change meaning of your X-ray imaging data set, then we need to refrain from using them. These are some examples we can see here. Like we have just added some transformations, we have shifted images slightly, and based on that we can make predictions on whether the person is normal or suffering from pneumonia. Self-driving cars, they are also looking forward for some robust models in this category. So data augmentation can be applied over there, because self-driving cars may also monitor huge amount of data from the routine traffic or road conditions, but people will not be so uh, ready to share that data set, because that involves privacy concerns. The camera recordings from self-driving cars may have information about the routine travel patterns of the person, and he may not be willing to share that information with anyone for the safety reasons. So in such cases, even if you have a small data set, data augmentation can help you to understand, and this will help you to improve the learning ability of the self-driving cars in future, because you can just understand the traffic behaviors on the road, and based on that you can update your car based software models over there. It is also useful in case of natural language processing, where we are just working around some textual information, and we just try some different word embeddings, character swaps, or random insertions, etc. So in those cases, your data augmentation will have a different role. It will not always be like slicing, or we cannot always say that zoom, etc. will work. For images, those techniques are fine. But when we are talking about natural language processing, and from there we need to generate more data set, the techniques may be different. Like here, what we are doing is we are just doing some replacements, insertions, deletions, or positive selections out of your data. So this is the actual sentence that we are trying to process, for instance. From here, we are just choosing different roles to apply on this sentence, like selective replacement we are doing from here. So what we have done is, this game we have replaced with show over here. Then selective insertion we have done. So in this case, we have added some information, right? Like your football we have inserted here, and then just some random insertions we have done, depending upon what is good for your data. Definitely based on that only we'll do insertions. Selective deletion, if there is some information that is not so relevant, we can delete that also. Or if sometime we just want to create multiple versions of a sentence, sometime we'll keep some information, sometime we'll delete some information, and we'll just focus on the relevant things out of that. Positive selection also, maybe the main focus is the basketball, so we are just using that, and we are just removing everything else. So this is how we just focus on some candidate words, and then we try to process them further to create your augmented samples, and they will be further used for training your model. We can also do these kind of things with the automatic speech recognition projects, where you will have like large number of noise injections are possible, shifting, changing pitch of your audio system. All these things are possible in that. Similarly, speech to text models also, they may require some kind of augmentation. There also we can apply some additional words, or maybe some additional techniques for pitching, etc. And GAN models are popularly used for these kind of applications to generate some realistic sounds. Like maybe we are training a deep learning system on certain kind of music, to maybe to detect a specific type of music, but you don't have enough samples of that music. So you can make use of a GAN model to generate that type of lyrics, or that type of specific tunes, and you will have a good population of data, and that you can use to build up your model further. These are just some examples that from the original data set, by inserting some noise, etc., you can just, on the same pattern, you can just enhance your data quality for the model building. So last part we need to discuss about this is, because every technique that we follow in the deep learning procedures, there are always some limitations that we have to talk about. Like first part is, it always inherits some biases present in the original data set because we are driving everything from there only. So when we are driving it, some biases will always be inherited. The advanced quality checks will be always required in augmented data to create some realistic models, because sometimes if your augmentation techniques are not right, that we have discussed already, that if we choose wrong augmentation technique, it is going to make your model even worse. So those things we need to get checked with the help of experts to ensure a good model building. There are plenty of complex augmentation techniques that can generate high resolution images also, but definitely more research and specialization in those fields are required, and we need to design robust models even for the augmentation process as well. Finding a good augmentation approach again is a difficult thing. There are plenty of things, like there are hundreds of methods that you can apply, but which one you have to choose, that is always a time taking task. However, even after all of these limitations that we have, this augmentation technique can definitely enhance performance of machine learning as well as deep learning models. So we can use, when we use them appropriately, they will definitely give good results to us. So this is just a quick theoretical discussion we have done, and in order to discuss it more in depth with how we implement it and what changes we get in the outcome based on this, we'll just proceed with little bit of implementations. And for that I'll be using different kinds of data sets right here. Will, depending upon how much time we have, I'll just give you a few examples over here. So all of us can now switch to Google Colab platform just to start building different augmentation techniques over here on a basic data set. So I'll also open up Google Colab platform. We'll be getting into a new notebook over here, and I'll just rename it and then we can start further. So in the first example, I'll be using a cat dog classification dataset, which is by default available in your TensorFlow datasets folder. So from there itself, we'll be calling it and then we'll be proceeding ahead with it. And if time permits, I'll discuss few more things also regarding this. So I'll call it day 4 possibly, and session 1. I'll just save it right like here. And the very first thing, as we always do, I'll just load necessary libraries. There are again plenty of libraries that we may need. I'll start with the basic ones. So we need NumPy as NP, the very first thing. We'll need Matplotlib if we have to plot anything. We'll require this. So Matplotlib, PyPlot as PLT. Then we have TensorFlow, that also definitely we need to get your dataset as well as to get different layers to build models. Then import TensorFlow underscore datasets as TFDS. From Keras, I'll just import layers so that whenever I need them, I'll just call them as per requirement. And before this, I'll just import Keras as well. So these are the elements that I'm just looking forward to. And if we need more, we'll definitely install them. So I'm just running it. And in the meanwhile, I'll open up the Sniper window where I can share code with all of you. I'll be creating one new file over here. So this is for day 4. So I'll be posting everything in this day 4 session 1 file so that you all can get it easily right here. Okay, so this code is running fine and I'll put it here in the chat box. I'll look forward for your responses in the chat. You can definitely use dataset size by using generative AI also. I have not worked so in depth with generative AI, but yes, you can do that. So I'll not be able to suggest you exact algorithm for that, but yes, that is the option is possible. Generative AI is one popular tool for generating your augmented data set. So let me know when you all are ready with these libraries, then we'll switch forward. I'll look for the responses in the chat box. Thank you very much for sharing. If you don't have Snipper link, I'll be putting it in the chat box right here. Okay, great. So I can see some responses right here. And now let us get our data set, and the technique for that we already know. We have used it yesterday also somehow. Today, the dataset folder that I'm going to access, it basically has three different portions that includes train data, validation data, and test data by default. So that only I'll be getting. It also contains metadata that will have label information, because that is not included inside. It is providing label information separately in the metadata folder. So all those collections I'll be getting by using load function within the tfds folder, and inside this I'll pass name of my dataset. Cat versus dogs is name of my dataset. Along with this, the split function I'll insert, and splitting how I'll just show you. First is the train dataset. I'm doing direct splitting here. There are so many ways to do splitting. What we are doing here, let me just mention it clearly. When we talk about data splitting, there are multiple ways to do this, and all those things have different impact on your output also. When we have a simple data set which is not affected by any kind of seasonal information, we can use direct splitting like I'm doing right now. What I'm doing here is I'm keeping first 80% data for training over here. Means in one section, in the first section, that will go into this. So main folder is train folder. That is within this load data set. From that only the first 80% will go into this, and from that train folder the next 80% to 90% that will go into the second category that I have listed above, is in the form of your validation data set. Then third set from that folder will be 90% and above. You can see how I'm using these columns. So 90% and above, that will go into your last portion, that is test data set. So what is happening basically, I'm using direct splitting. That means first 80% in one side, then next 10% in validation side, last 10% in test sides. But in case if you have seasonal data in some applications, in that case we do not recommend direct splitting. What will happen if you do direct splitting in that case? Because with direct splitting in that case, you will not be able to preserve seasonal information within your model. And with that loss, what will happen is, for instance, if we have 12 months of data from your model, we are getting 12 months of data. In that case, if I split my first 8 months for training, and then maybe last 4 months I'll keep for testing, or even if you can add validation, what will happen? Maybe my model will learn better about few seasons, like maybe spring season, summer season, uh, 1 2 3 seasons, based on how we are splitting in the beginning. It will have good information about that. But maybe your data will not be trained on winter data set, because that winter data set I have splitted in the beginning and I have put it in the testing data set directly. So okay, my model is learning on 3 seasons, but fourth season it is missing, possibly. And when I'll try to test my model on that fourth season, which was only in the testing data set, it will definitely fail because it do not understand what is the pattern of that season. So this is how we always have to be careful about splitting. When you have to do random splitting, when direct splitting is possible, that careful selection you have to do based on your domain selection. Generally it is always recommended that you go ahead with the random splitting, so that you don't have the issue of season anywhere. But still, if you are very much sure that in your dataset there is no seasonal information, you can go with the direct splitting also. Like for instance, in my case, I have just a cat dog data set, so there will not be any seasonal information in this, just images of cats and dogs, so that will be same in all seasons, so that we can apply directly. And after this, few parameters I'm updating here. With info, I'm making true, so that all the information that I have within these images, that is transferred into, along with the metadata, means label, etc., everything is occupied within this. And as supervised, I'm also making true, because the model building process I'll follow with the supervised learning. If I want to do any unsupervised learning or pattern analysis only, I can make this unsupervised, this supervised false in that case. So these are some initial settings I'm making. Let me first run it, and if it works fine, I'll share this code. We just need to ensure that if we don't have any typo, so it looks like it is working fine. So while it works, I can share it with all of you so that you can also get your dataset ready on the system. Let me know when your dataset is loaded with 100% over here. It will also generate split for all the sections, so it will take some time. In the meanwhile, all of you can run it and let me know when it is ready. I look forward for the responses in the chat box. We are just getting our data set with exact splits over here. The technique that we are learning here, you can later on apply it on the two datasets that we have used in the previous sessions also, like on Cypher 10 dataset or maybe MNIST dataset. As a beginner, you can just experiment it over there also for the augmentation, and you can see how your model is performing. Let me see, we have a typo over here. I'll just see if there is some error with the code right here. Just let me verify. Okay, so this portion I have made a mistake over here. I inserted it inside. All of you may be having the same error. Just let me run it. This should be fine now. So I'm just replacing it here. The middle train we have placed at the wrong place. It should be outside brackets. So that was a typo I made here. Now the data must be ready. And let me just add one more part. Get number of classes. All of you can just report me if your dataset is ready, if the error is removed. I hope you all observed what I did just now. We had a typo in the previous code. If you all are suffering with that, you can just take new code from the scraper and it will work fine. Okay, great. Thank you for the update. Let us see number of classes in this particular data set. So as I told you that this information is within the metadata. contained inside my data folder. So from there only I'll get it with the help of a specific function. I'll just use features option from there, and I'll use label dot number of classes, and ultimately I'll just print these number of classes right here just to see what we have. You can try this with different types of datasets. These are just some samples we are trying. That if you are not aware about number of classes in your dataset, you can use this simple code to get that information. Let me know when you all are getting this. Thank you very much for the update. So let us see first few images of this particular data set just to have a visualization of what we have inside. Before I apply augmentation, let me see what is the original version of my data. So what I'll do here is get label name. I'll create a small sequence of code over here just to extract relevant information for plotting my features, plotting my images over here. I'm just converting my label from int to string so that I can have specific names for it, that it will automatically extract from metadata. Metadata has both things, labels in the form of int, labels in the form of string. So int type labels will be like 0, 1, and string type label will be like dog and cat wherever it is applicable. So I'm just getting the string information from that, and then I'll go with the iteration over my training data set. So that we have just stored in train.ds. You can see this is the name of my training data. So what I'll do is I'll just iterate through my training data set by using iteration function over here. Then we'll try to create a figure, and for that first I'll just decide size of that figure, because I'll be adding multiple images into that figure with subplots. So for instance 7, 8, you can use any size and you can plot any number of images. I'm just using one sample over here. Image size or figure size description I have added. Then I'll just run a for loop for x in range of 4, because I want to plot 4 images right now. So you can do it with more images also. Image and label I'll get from next to next iteration on my train dataset. So this I'm getting that iteration saved into the train ITR, and on that I'm just shifting next to next while building your model right here. And then figure dot add underscore subplot, whatever I'm extracting from here one by one during my for loop, that I'm inserting one by one into the for loop. So 1 comma 4 comma x plus 1. What does it mean? I'll have one row, I'll have 4 columns, and then starting from x0, because when I'm saying range 4 means it will start from 0, 1, 2, and 3. There will be 4 elements. Range function always start from 0 and it will end 1 less than the given value. So that will be 4 values basically, 0, 1, 2, and 3. So when it will start from 0, so it will be plus 1, means first position for the first image on the subplots. Then we have plot im show image. After this plot axis information, I'll make axis off for now because these are just cat and dog images, so axis may not be required in this case. We need not to have anything on the axis. And then title I can add. So the title I'll just update by using label name, so that with the image itself its label will be displayed as a title. So I have written it here, and from here I'll extract the label directly. So this should be fine. Let me run it. So you can see these are first 4 images that I'm getting. 3 are from dog and 4th is cat, because there will be a random distribution of the images, accordingly it is getting. So I'll just share this simple code for the plotting purpose with all of you. Just run it, get your images, and let me know if it is working fine. I'll wait for the responses in the chat box. Thanks for the updates, everyone. So we have just seen a few images over here. Before I apply augmentation on the entire data set, because in that case, it is like we are not just going to view the entire data set, that how augmentation is applied and what are the changes in the data set. So just for your view that how this augmentation will work step by step, what I'll do is first I'll just choose one image and I'll apply multiple augmentation techniques on that just to see how the image keeps on changing. So I'll just, for example, start with this first image only. I'll apply different augmentation on it and we will see what will be the impact on this image. So once we learn these augmentations one by one, based on whatever we studied theory, we are just linking it with them. That if theoretically we said this, how the impact goes with the real image. After studying that, we'll apply augmentation on the entire data set and then we'll put it into a model. So that we can do. So the very first thing I'm doing here is get one image, because I'll be using only one image for the basic augmentation learning here. So what I'll do is image and label. Again, next ITR from my train DS and plt.imshow. The first image only I'll plot now. plt.title, get label name, and inside this I'll pass label. Let us run this and we have this image. Only on this image I'll be doing operations initially. So I'm just picking this one and I'll be sharing it with all of you. You can also get this image, and now in my image variable I have this particular image on which I'll be making operations. So further I'll be applying augmentation technique. First let me know if we are all done up to the same level. Thank you for the update. So now I have inserted here the main task that we are going to follow further. Apply various segmentation techniques to observe impact on dog image. See, there are plenty of ways to apply augmentation on the dataset. Like you will find different libraries, like one of you just mentioned that can we use generative AI. Yes, we can use generative AI for that. Similarly, there are plenty of libraries you can use it from the sequential models also. There also we have different augmentation technique. From the TensorFlow itself we have image data generator. From the Keras also you will find different augmentation technique. So it depends on how you want to use, which interface or which framework you want to use to apply data augmentation. Accordingly, you have to write your code. Here, depending upon how much time we have, I'll just show you one or two examples. One I'll show with your TensorFlow, that how we with the TensorFlow image generator. That is one image generator function that we can use. And second, I'll show you with TensorFlow image option. Two things we'll use from the TensorFlow itself. Later on, you can try with different libraries also. So the very first thing what I'll do here is create a visualization function. This is one additional task I'm doing here. And why I'll be creating this function basically, so that whenever I apply a augmentation technique on my image, I can print or visualize the original and augmented image together. So for that, I'm just going to create one function at a time, and then whenever I have to plot those both images, original image and changed image, I'll just call this function throughout the process, and I can just quickly visualize my image. So this is just to reduce coding further. We'll just one time create a function of our choice. So I'll create the function name is visualize over here. Two parameters will be passing into this whenever we have to use this. One will be the original image, other will be the augmented image. And inside this, I'll just pass few things over here. First is will create a figure. So I'm not adding any dimension to that. It will take default dimensions automatically. Then we'll go with the subplot 1, 2, 1. So inside this, first one is my original image I'll be plotting first. So original image will be the first title. We'll use I am show, and that will be the original image. It will be based on what we pass here. Accordingly, it will take the value over here. Then plot axis, I'll just keep off because I don't want any axis information to be displayed. Same I'll do for the augmented image also. For instance, I'll just pick this information. I'll put it here, and I'll make small changes, like I'll put it on second place. I'll call it augmented image, and I'll just change this one also to augmented, so that this one gets plotted in the second subplot. So this is a simplified visualization function I have created. I can run it, and it will be saved in the memory of my system, so that whenever I call it, we can use it. Whenever we create a function, if it is right or wrong, we'll not be able to analyze right now, although it is giving us a green mark. But when we'll pass this function, then only we'll be able to verify if we have created it right or not. Because when we call it, then only we'll get an error. So now start with first method, flipping. You will see that this is very simple to do. All these methods are very simple to apply. So what I'll do is I'll create a flipped image, and I'll take help from TensorFlow image module. And there I have a direct function, flip left right, and I'll put image inside this. So it will automatically flip your image left right with the default values. And we'll just pass the visualization image flipped. I'll write here, and let us see what we get in the output. See, this is original image, and this is the flipped image we are getting. So whatever we have as a default parameter for this, I just recalled someone yesterday also asked that how we know about the default parameters. So for that, there is a very simple process. Let me just give you an idea. Whenever you need to know about default parameters of any function, whether from machine learning, from data science, from deep learning, as a beginner, what you can do is you can always visit the official website. For instance, you want to know about default parameters of this function or this process, just copy it, go to your browser, and then search it with respect to Python, and you will go. There is no need to find any tutorial for this. Just go to the official website from where you are getting this function, TensorFlow. So I'll just go to the official website only. That is the most reliable source you always have. So on the TensorFlow itself, you will see we have all information about it, that how we apply it, what we have inside this, like what image information we have, the tensor shape that we pass over here, all the relevant information that you need about it. It says flipped along width dimension. So that we have seen in the output also. So it automatically will flip image based on the its width dimension. So that only we have seen right here. Maybe someone is getting error. Could not load the JavaScript files needed to display output. This is probably because of the Google account login access expired. This sounds a little different to me. uh, I have, I think this is, you can just try to log into your Google Colab again, sir, and then maybe you can try running it again. This is just because of some issues with the Google account. I think we cannot help it with the coding. You just try to log in again. Maybe you are not getting direct access to the CPU on the Google server right now, so that is why this error may be appearing. Try logging it again. First save your data sheet and then only go back, so that at least whatever you have executed, that stays safe. So after checking, okay, so parameter I have shown you, that quick information about it you will find here, and from here you will come to know that this will flip your image by width dimension automatically. Similarly, if you want to see, like for instance, someone wants to know default parameter of any machine learning model, like I'll write here random forest classifier. So always go to sklearn official library only. Don't go for any tutorial. This is the only reliable source you can find. So for this, what we'll do is I'll just open it up. You can see this is your random forest classifier, and these are its default parameters. Everything is listed here. Everything in terms of what is the default value, like criterion, it is following Guinea, and minimum number of leaf samples, it is following 1, minimum sample split, it is following 2. So default values along with default parameters it is providing here. Along with that, what you will find on the official source, information about each one of these parameters that we have here, what each one of them mean. If you scroll down, see what is the meaning of n estimators, that information you will find. What is the meaning of each one of these criterions, that information you will find. So when you scroll down, all information about default parameters will be here. So after learning the technicalities behind it, then you can tweak your parameters based on how you want to hypertune your model. This is useful for all kind of Python functions, all kind of data science, deep learning and machine learning projects. This is the most genuine way to get information about default parameters. However, when you go ahead with the regular practice on these things, you will automatically come to know that what are the default parameters these are I'm using. But yes, as a beginner, you can refer to these sources. So after applying method 1, let me try one more thing over here. So what I'll do is, for instance, I'll use grayscale. I'll just try to add grayscale. This is one of the techniques we have seen in your color transformations in augmentation. So let me see what we can do is, there is again a simple function. I'll get a grayscaled image from df image.rgb to grayscale, a direct function available. Inside this, I'll pass my image, and then I'll write here visualize image, and for instance, I just pass here grayscaled image. Let us see what we get. If we have any error with this, I'll tweak a parameter over here. First, let us see this in the real format. So this is the outcome we are getting. Sometimes we can even squeeze our outcome images. That is also possible. This flipping I have used already as a method 1. If you have not received this, I think, okay, I can understand. I'll just put it here. Let me know when you are ready with the flipping, and grayscaling also I'll paste in the meanwhile. I'll wait for the responses in the chat box. You can see simple grayscale shift we have done on the image, and by some default value only we have done. We can even pass parameters for the specific value, that by this amount we can do grayscale. But since I'm considering that we are doing it for the first time, so we are not tweaking any internal parameter, just the default change we are seeing with the augmentation. Thank you for the update in the chat box. Let me add one more item over here. So method 3 I'll update is, for instance, we will adjust saturation. This saturation adjustment is also a part of color transformation. hue transfer we can have, saturation transfer we can have, grayscale transfer we have, all possibilities are there. So I'll create here saturated image tf.image dot adjust saturation, will pass image, and the saturation parameter, for example, I'm passing 3 over here. There will be a default value also, but for instance I'm using a value of 3. You can also see range of value on the official source, that what range of value it will take as a good option. So then I'll pass here saturated and original image into the recently created visualize function. Let us see what we have. So this is my augmented image right now. You can see that we are preserving information of the real image only, but with a slight change in terms of its appearance. So the main features will be preserved as it is, but just the impact of the image we are trying to change here, so that your model can have diversity and variety of data, and it will become more robust when trained on such variety of data set. Let me know when you are done with the saturation. These are very simple techniques actually. So we just update the values and we just pass them into the model and the process is done. But still, they are very useful. Easy, but still useful. So the next method I'll insert here is method 4, that will be to adjust hue, for example. So I'll just create hue adjusted image over here. Any name you can give. I'm just giving some random names over here. Adjust hue parameter, image, and delta value I'm passing is 0.1. That by what level I'll adjust hue, just one parameter I have passed over here. You can change the value and then you can see the impact on your image as well. So I'll just write here hue adjusted image for the print. So this is my current value. For instance, if you want to change it, you people can also change it in the meanwhile. I'll put it here. So for instance, the delta value instead of 0.1, I'll make maybe 0.4. Let us see what change we'll see. So you can see slight bluish impact it is getting right now. And maybe I'll make it 0.8. Let us see what we have with that also. We can have a different tint over here. So these are the changes we are making with the help of hue adjustment. Same you can observe with your saturation adjustments. For instance, currently I'm having here value 3. If I make it 1, so I'll run this. And you can see the 1 is the default. It is not making much changes. 2, I'll check. Slight change, slight darker saturation value I can see. If I do it 4, let us see what we get. Let us see. More darker texture we can see here. So you can observe one more thing here. Even with a single parameter adjustment, if you run a for loop, just for instance, if you run a for loop with a range from maybe 0 to 10 for the saturation, how many number of images you will get from there only? So even by using only one augmentation technique, you will be able to generate 10 different images maybe, or 20 different images. Just be sure that which technique you are using and how useful it is, or what range is preferable in your kind of data set. Then you can create any big set of images from there itself. So hue we have done, and I hope I have shared it as well. Yes, I have shared it. So after this, let us try one more thing. Like for instance, we have discussed about brightness changes also. So I'll add one more method over here. brightness adjustment. So I'll create here a bright image with the same process, df image, adjust underscore brightness is my function. And inside this, I'll pass image parameter with a value of 0.4. And then I'm writing here visualize image, and the second image I have created is bright one. So let us see what we have. You can see little brighter texture of your image. Again, we can change values. For instance, I want to make it 0.6, more brighter. So it depends on what level of brightness is comfortable for your kind of images or models. Accordingly, we can use. So I'll just put it here. And I'll update your method also right here. Let me know when you are done up to this. Thank you for the updates. So let us add one more technique over here, like for instance, cropping we will do on the image. So now cropping is possible on various levels, like on the corners, on the middle, wherever you want to do cropping. Accordingly, you may have to pass a parameter. So in my case, I'll just use one parameter. You can later on try it with the different parameters also. I'll use image with maybe a central fraction. So I'll just crop it from the center, means I'll just focus on the central portion. For instance, I'll use 0.5 or 6, something we can try. Then we will visualize it with image and cropped image right here. So we have augmented it, just focused on the middle portion. Let us change value. Let us see what we'll get. So this is how we can crop it as per our requirement, and we can update the value. So I'll just share this one. So if you are interested to know what are the other cropping possibilities, again, you can go to the official website and we can find here what are the other possibilities for the crop. For instance, what they say is we generally prefer central fraction for the cropping purpose, and the default value also is 0.5, but you can change it for the larger dimensions. So they have mentioned everything about it right here. It will change your value based on how much cropping you are doing. Like if you add 0.5%, it will do central 50% cropping based on this only. So if you need more information, we have everything right here, that whatever changes, it says that we can change it from 0 to 1, and accordingly the size will be cropped. So this is how you get more information on any function when you are applying it. Then we'll go with another method over here, that is rotation. This one also we have discussed. We can rotate images. Although this method will not be suitable for all your datasets, because every time rotation is not a reliable option. Some images will lose its meaning when rotated randomly. But for some images, even rotation is good. So we can just try it, and you can decide later on which dataset you can use it. So for this, we have rot 90 to rotate by 90 degree direct function we have here, so that we can use immediately, and we can put here to visualize image, and this is my rotated image. Let us see what we have. So this is my rotated image. So if this kind of rotation goes fine with your data, you can definitely choose it and you can proceed with it. So 7th method I have updated in the snipper window. All of you can try it and let me know if it is working fine up to this. Thank you very much for the update. So one last technique on the single image I'll try. There is one technique called random brightness. A single value brightness we have already tried, that is with a fixed value of brightness, with a fixed delta value we have tried it right here. A fixed value we have given. But there is also possibility for random brightness level, like you can do multiple brightness changes by using a for loop that I discussed in the middle also, that if you want to apply a range of values for a single augmentation technique, even from there you can generate multiple images. So let me just give you a quick idea of that also, maybe if any of you want to use that technique later on. So for I in range 3, for instance, I'll write here, I'll add one seed value that I'll use further for your updating your final image in your different subplots. So that will go with the for loop right here. So what we'll do here is stateless random brightness. The technique we call is stateless random brightness. So with the same name, I'm updating the outcome. tf.image.stateless random brightness. And inside this, I'll pass my parameter. One is image, second is maximum delta value, means from minimum value, the default value it will start and it will go maximum to 0.95. And seed value we have already decided on the top, so it will just follow it from here and it accordingly it will keep on placing things. And finally we can visualize, and for that I'll place, this one is extra, so visualize I'll add here. And inside this, one thing I'll pass is my image, and second thing is the obtained from the method itself. Let us see what we get in the outcome. If it works fine, I'll share it with all of you. So you can see with different brightness levels. So on this side, we are getting the original version of the image only. And on this side, we are updating with some changes, some random changes in the brightness levels. So this is how you can compare multiple levels of changes by for loop itself. Just let me know when we are all done up to this. Then I'll apply augmentation on the entire data set. Thank you very much for the updates. So I'll write here the next task, apply augmentation on entire training data set. And for this, first I'll create a augment function in which I'll declare all my methods that I want to use for augmenting my images. I'll not apply so many methods. I'll just use few to three ways over here just to update my image sequences. So first define augment I'll use over here, image dot label I'll update. Then first is your normal resizing technique I'll apply that we already know. So that can be also a part of your augmentation because that is also changing size of your image. So image I'll update here, and inside this I'll pass image underscore size variables. These I'll have to declare. Either we can pass value, or I can pass variable whose values I can declare below. So currently it will show me some red lines below because I have not yet declared them, but I'll declare them below, because before this function call only we need to declare them. Second thing I'll do is my normalization, that we already know how to do, divide by 255. That also I'll consider a part of your augmentation right here. So it means I'm updating all layers within the same function right now. So tm image dot, for instance, I'm applying one random crop. There is a random crop technique also that we can use. Size, for instance, I'll use based on this, and comma 3 from your this size information we are updating based on what level we are doing to this crop. So this variable again we can change as per our requirement. So this I'll pass as size is equal to, and this we don't need, df dot image dot random brightness also we have seen already. So that I'm passing here with max underscore delta value is equal to 0.5, although by default also it is same. So if we don't pass it here, then also it should work. Then we have the return value, image comma label. Two things we need as a return element from when we apply this particular augmentation technique. So this should be fine as a function, and I'll be sharing all these things because I will be adding more code syntax below. Once I complete it, then I'll be sharing this entire thing. So function definition is complete. If I want to add more augmentation technique, I can put them here in sequence accordingly. First, I'll try only these, then later on we can try more also, and then we'll see what changes we see in the final outcome. Again, I'm mentioning that it is not always essential that what augmentation technique we use first, only that will be fine with your model training. Sometimes your selection may be bad also. So in that case, you have to replace your techniques. You may have to use any other, you may have to remove some techniques. So auto tune also I'm turning on. This auto tune will help you to prefetch all the relevant information required for the default settings of your model, as well as for updating data values whenever required in your transformation. So we are updating here train DS dataset. Although we have the train DS dataset already. So you will see on the top when we called our train DS dataset, this is the variable name I'm using. So either you can use same variable name to for the transform dataset, or you can try different variable name. In my case, I'm using same variable name only. And inside this, I'll pass first my train DS, the original one. Then shuffle, I'm turning on here 1000, so that all images get shuffled while getting this update. Second thing I'll do is, I'm just passing one by one all the elements. Second thing I'll do is map augment, means now I'll apply my this augment function from here on my training data set. And for this I'll add here num parallel underscore calls function is equal to auto tune. So it will auto tune my entire data set based on the augmentation function, and the virtually created data set will be updated into the system internally. Then we have the batch size here, so that I have declared already, so that I'll pass here. Then we have prefetch over here. This one also I'll do auto tune, so it will automatically prefetch the images from my train DS folder, and it will keep on updating them based on the augmentation function that I have applied right here. So this should be fine for the training data set. And for instance, because when I have called this particular data set, you can see here we had a validation data set also. And when we fit our model, we pass both train as well as validation dataset. So in fitting process, both your datasets that you pass, they should be of same dimension and same shape. So that is why we need to add validation dataset also into this augmentation process. So what I'll do is I'll just copy this entire thing and I'll pass it to my validation dataset. This one I'll change and only this one I'll change. Remaining all things I'll keep as it is. That should be fine. So I'll run this part and let us see. I'm getting one error. Let me see where I have typo. I'll just correct it. Right here. Fine. This one I need to close after this. So that will complete my image size. So this is now a green tick. I'll share this entire information in the snipper window for all of you. What I'm doing here is applying data augmentation on entire dataset. Entire dataset, when I'm saying, that means two portions, train and validation, because we do not augment testing dataset. That is not recommended. So I'll update this into your chat window also if someone is using it from here. So in two portions, I'll be adding it. Let me know when you all are done up to this. Thank you for the update. I hope all others are also doing it side by side. I can see few updates. Thanks for this. And now I'll just build a sequential CNN model. Only a basic model I'll build. I'll not go in depth because the main purpose was to understand augmentation. Model building and compilation process you already know. So I'll just give a quick reference to this, that how we put in your augmented data inside your model. The process is exactly same as we have done. So we'll just run one iteration and we'll just verify that everything is working fine with the augmented data set. Later on you can try it with anything on your data part. So I'll call a sequential model from here, from the Keras layers. This process we already know. So the same technique I'm using here. I'll go to layers. I'll get my convolution 2D layer as my first layer. I'm passing 32 filters. The kernel size I'm putting is 3x3. After that, I'm adding padding is equal to same. We have discussed all these concepts already, so I'm not repeating it again. So I'm updating my activation function also as relu. After this, the second layer I'll add is max pooling layer, one of the most essential layer we have inside after convolution. And inside this, the common pool size we can pass same as we have done earlier, 2x2. This is the most common and most suitable pool size for a small data set, small size of image basically. Then layers dot flatten I'll add without any physical parameter, only the default parameters will use for the flatten. Then we have layers on dense, that will be the ending part. I'm not creating an in-depth model right now because we don't want to put more time for its training. You can later on build a bigger model and see the impact of data augmentation on your final model. You can change augmentation techniques also on that, and then you can see what changes you are getting in the accuracy or overfitting issues in your model. So that slight change you can definitely observe. So this should be fine. We have updated everything for a basic model. I'll just run it, and if it works fine, we'll move further. We have one, okay, software. There is an autocorrect. We need softmax. So I'll just run it. This is fine, and I'll share this model with all of you. All of you can run your CNN model, and then we can just compile it also. You can check model summary also. That is also your choice. I'm not checking model summary right now. I'll just compile it after this. The basic processes we know already. We are just trying to fit your augmented dataset inside, and we'll just ensure that whatever we have applied, that is working fine. Compile and optimizer. I'll add this again, Adam. Tomorrow we are going to discuss about these optimizers also in detail. So there I'll show you a few other optimizers as well. Loss function, binary cross entropy I'm using right now. Earlier we have used, I think, a sparse cross entropy, and one more we have also used. Today I'm using binary cross entropy. You can try a variety of loss functions depending upon the pattern of your data set, because currently I have only two classes in my data, 0 and 1, two classes. So binary cross entropy is suitable for this. When you have multiple classes, you may have to go with other cross entropies, that we have sparse cross entropy and other also versions you will find. So the metrics I have updated is accuracy. Now the remaining details I'll add here. Epochs, only one I'll run, otherwise it will take so much time. Even for one it will take some time, so we'll just do other discussions in the meanwhile. So I'll just run train DS over here, then I'll pass validation dataset in the form of validation DS. I have saved it. Then epochs I'll pass in the form of this variable itself. No other setting I'm applying. You can apply it as per your requirement. We have learned several settings for this also earlier, like verbose, etc. You can apply as per your requirement. Currently I'm running it like this only. So let us see what we get. It will take a little bit of time to run your model, because we have augmented it and there may be a huge amount of images generated behind, so that will take a little bit of time for model training. In the meanwhile, we'll discuss few things further. I'll just share this one with all of you so that you can run it side by side in the meantime. Since we have increased image size right now, your data size right now, so it will definitely take some time. Someone has raised hand also. If you have any query, please let me know.
Ma'am, just I want to know how we can create mask of an image. I am doing some experiment on some data set and I required the mask for a particular image. How I can generate if mask is not given? Yesterday I also asked this question.
Whom you asked this question, sir?
How we can create a mask for any image?
Sir, I may need to check for that, because currently I just need to finish on this augmentation part. If you need any source for the masking information, I'll try to find some sample codes for you so that you can implement it later on,
Yes,
because in
ma'am.
detail I'll not be able to do that right
Please.
now.
If you can find, please provide me.
Yes,
Okay.
tomorrow I have one session, so in that I'll try to share it with you.
Thank you, ma'am.
Okay, sir. So we are currently running this part over here, and in the meanwhile, while this is running, I'll show you one more technique for augmentation, that is with image data generator. So while this run, let us see one more part. And see, I'm not just doing any testing, etc. for this model, because we just need to ensure whatever we have done with the training data set, that is fitting fine inside model. Later on, you can do other things with this. So we are just verifying whatever we are doing. The accuracy will not be so good right now because I'm running just one epoch. So if you can later on run it with like maybe 50 or 100 epochs, you can observe what accuracy we are getting from the model. And one more thing you can do is, I'm just giving you options that you can try. Maybe as an assignment also you can try this. One is I'm using it with the train DS with augmentation. One more thing you can do is just change name of this data, give it any other name, then train your model twice, one with the original DS and other time with the augmented DS. You can give it maybe other name like train augmented DS. So one time you train model with original DS, other time you train it with augmented DS, and then you can see what change you are getting for the accuracy. You run it for the same number of iteration and look at the accuracy values, and note that it will not always be just the accuracy change. You have to look at the overfitting also. it depends on what type of data set we have created and what type of augmentation we are implementing. Overfitting is the main criteria that we have to follow. If with the original trained DS dataset, maybe your model is giving accuracy like it is 98% for training dataset and it is 96% for your testing or maybe validation dataset. So you can see there is a gap of maybe 2 points or 3 points between your training and testing dataset. But then you apply augmentation and test the margin or the gap after augmentation. It should be recovered by some level. Like if 98% you are finding with the original training dataset, it should be somewhere like 97 point something, close enough to your 98 with the augmentation also. So that will help you to provide your analysis that how you are recovering overfitting. So plan to do that with different value of here of augmented dataset here. When we train our model for trained dataset with augmentation, can we know how many more images we get? Yes, you can do that also. Currently, I'm not doing that. Definitely, you can try. In that case, you can even save your augmented images into a folder within your maybe drive or maybe on your any system folder, and you can see how many images are updated into your system. Generally by default they will not come in front because they are stored virtually behind. But yes, there are some functions, there are some methods that you can try, and you can update that to see the level of images that we have inserted over here. So in the meanwhile, one important part I have to show you while this is running, I have to show you another most popularly used technique for augmentation, that is method I'll add here is image data generator. This one also you need to understand because in most of the research papers you will find referenced for this one. This is one widely used technique. So let me give you one example of this. I'll not create entire model. I'll just use few lines over here with Cypher 10 dataset that we have used yesterday. You can try it with any other dataset also. So I'll first call that dataset right here, y_train. The same technique as we have used yesterday, the same I'm going to use here, x test and then y test. I'll update. So keras.datasets.cypher 10 I'll add here, and on this I'll apply my load data function. All these things we have discussed yesterday, so the same I'm using here. Then I'm using a data gen variable over here in which I'll pass my image data generator augmentation technique. So I'll get it from Keras pre-processing package with image. It will be image data generator. This is the name of the function. And inside this now you can pass multiple parameters. For instance, I'll apply first augmentation my rotation range. Rotate by 20 degree. First time I have added. Then I'll add width shift range equal to 0.2. I'll shift width by 0.2. Then I'll add, for instance, height shift range. Just some common parameters I'm adding for augmentation. All these we have discussed already. We are just applying it right here by using another function, that is your image data generator function available. Another technique for the same thing. Flipping, for example, I'm just making it true so that my image get flipped out also. And validation split also will apply within this pipeline only. So 0.2 it will do validation split. See, this is also another important thing you can try. Like when we are designing your augmentation, there also you can apply validation split, that how much data you from this augmentation you will pass to training and how much for the validation you will pass. So from there only 2 batches you can create automatically and you can save them separately. So I'll use this datagen.fit now on my xtrain dataset that I have created recently. This is this one dataset. I'm just applying my this variable where I have stored all my augmentation, and it will fit my xtrain dataset, means new images will be gathered inside this. And then we can just visualize your images, although they will not be so clear because we'll create them on a smaller graph over here, but still you can see that we are getting some updates in your images. Like I'll add flow here, xtrain, comma Y-train, this data gen flow. This is the technique to apply now your this data gen function that we have created. We have fitted xtrain on this. Then this flow technique we use generally to extract things further while we are applying it inside the model as well. So these functions you will see commonly while building these kind of models. For I in range 0 to 6, for instance, I'll use plot subplot. The technique we already know. I plus 1 I'll use just to scroll through all the subplots. Plot show I'll take images from X batch, because X batch will contain my actual image information and Y batch will contain your label information. So this I'm updating here. Then PLT axis information I'll just keep off. For example, right now I don't need any axis information. And then I'll just break my for loop. Once all these things are updated, I'll just break my for loop. Let me see if everything is fine, and this will go to normal level. I'll run this part. So you can see this one is also running in the meanwhile, and we are getting some accuracy because the dataset may be very big right now, so it will definitely take time even for single epoch. Although it is only up to 75 here, so this must be close enough right now, and 75 total batches it is running right now over here. So the second one will run after that only. So in the meanwhile, I'll just share this with all of you. I hope it will be right, and if we have any error, I'll be correcting it. I'll write here what we are doing. This will be after this method with image data generator for augmentation. I'll put it here also. Okay, someone has received accuracy already, so this is good because this is just one cycle we have run. So definitely accuracy, we cannot ensure that this will be very good in one cycle only, but still we are getting something, and we are just ensuring that your augmented dataset we could pass into the model compilation and there was no error related to dimension, etc. So that we have verified from here. And the second technique also is running now, and we have just verified it that we can apply this second kind of image data generator as well on any type of your data set. So you can, same technique you can try with the MNIST data set, with Cypher 10 data set or Cypher 100 data set. You may just need to vary these values or these parameters based on your requirement. And if anyone is interested to know that what other parameters you can pass inside this, because we have lesser time over here, so I cannot pass all the parameters right now. But again, if you want to know, there is a very simple technique. We can again go to the official website and you will see there are plenty of parameters that you can pass. It is a long list. See, these are so many parameters you can pass. Currently, I have used just few of them. You can use many of these based on your requirement. Many of them are by default false or none. You can update values inside them, and accordingly you can update. The detailed information about each one of these parameters you will find in sequence over here, that what each one of them mean. You can see if you just scroll down, information about all these parameters is given, that what they are going to do into your model. So here, this is one good reference. You can see, like if you have one kind of noise you want to pass, that you can pass from here. Width shift, height shift, this we have already used. Rotation range we have already used. There is one parameter, shear range also, zoom range also, and then channel shift range. And this channel shift range probably will work with RGB images. So accordingly, you can make selections and you can update your dataset based on this. So this one also we have done. You can see little bit blurred images we are getting right now, but still you will just understand that we are getting the shift also. So if you compare it with original images, you plot them side by side, and then you plot your augmented images also, you can just observe that what changes we may be getting. So this is just a quick information about how we are applying augmentation. And yes, for one quick comparison, I'll just show you. I have applied one kind of augmentation on MNIST dataset that we used on first session with this deep learning project. So for instance, here I'll show this one to you. MNIST dataset we have trained on the, I think, second day. And in that dataset, we were getting accuracy somewhere around, I think, somewhere around 99% for your training dataset, and maybe 97% for the validation and testing dataset. So what I did is I just tried to see what impact I can make on this with augmentation. So I just everything is same that we have already done, just the augmentation part will be added in between. You will see here this augmentation I have added. So I have tried it with different parameters. You can see some of them I have made comment right now because they were destroying performance of my model. So I made hit and trial with various parameters. I just tried one, I just tried two, I tried a combination of three, four, and then ultimately I saw that when I turn on only these two parameters, my augmentation is working fine. And of course, this one also. When I turn on these two parameters, my model is having worst performance because they may not be suitable for this kind of data that I'm trying to train here. So these hit and trials you may have to do time and again, that which parameter is more suitable for your data augmentation, depending upon what we have in those images. So when I trained it with this one, then I build my model with the basic only. This basic model only we have built on the first day also. We didn't add so many layers inside. And then I trained this one. So you can see right here, by the end of this, what I was getting is, you can observe it here. This is 98.16 and this is 97.53. Although on the first day, your accuracy was 99, but there was a huge gap between your validation and training data set. That was your overfitting issue. But now what we did is we just tried to balance it. There the margin we have reduced. So you can see that here also the margin is reduced between both of these. If you plot with the original one, the margin will be more between these accuracy lines. And the same we can see with the testing also. This is on also 97.24, which is close enough to your training accuracy. So this is how overfitting also we can improve with this augmentation technique. You can try it with your dataset and then you can see what you are getting in the outcome of this entire process. So this is, I think, all from my side about the augmentation technique. We have discussed plenty of things, and I just hope that this will be useful for all of those who are planning to implement some model, deploy some real-time data sets on the models, because for the real-time data sets, definitely augmentation is one more important concept you may have to apply. So let me know if we have anything to discuss, or you can put in the chat box, or maybe you can turn on your mic. If we get more validation accuracy than train accuracy, is our model good? See, the main point is the margin should not be like so much. Then you can also be little doubtful that how your training is not good, still your validation is getting good. Margin should not be very big. But still, if there is some variation, it is possible that validation value is more and training value is less. That is possible, no issue in that. But that sometimes happens with the seasonal data set. Yes, this much will work. This is not issue. But if it happens with the seasonal data set, then you have to be little fearful that why your model is not good with one season and other season. But for other data set, this will go fine. There will not be an issue. Anyone else? If we have anything to discuss, please let me know. If you are working on mango leaf images, see, for mango leaf images you can apply flipping also, that will be fine. You can apply rotation also, because it will not affect. A leaf will still leaf even if it is in any direction. So rotation is good, flipping is good, even a little bit of vertical and horizontal shift will also be good if your leaf is not completely cut. You can apply cropping also to ensure that your leaf is in the middle, and the background unwanted things you can cut down, and just a closer look for your leaf you can get. And zoom will also work. If you have a very widespread image of the leaf, then zoom will also work. So these are the rotation also will be a fine option, that also you can try. For the mango leaf images or any kind of leaf images, plenty of augmentation techniques are fine. They will not destroy your dataset quality. We have to be more careful about this when we have some like direction specific, like maybe human beings we have, or maybe animals we have, because there has to be a specific dimension. The head and legs, everything has to be placed well. If we just turn it upside down, then everything is lost. So in those cases we have to be more careful. In most of the nature images, maximum augmentation techniques you can apply easily. Anyone else? If we have anything, we can put in the chat box and I can discuss, or maybe if you can turn on your mic as well. How to decide dimensions of image for models. This is definitely a little bit challenging, because you cannot decide a common dimension for all the images. This completely depends on the distribution, how your images are distributed. Like for instance, when we talk about the MNIST digit dataset, your digit is in the middle and outside boundary is your black. So in that case, you can even reduce dimension easily. But when we have like some images where the boundaries are also important, and we cannot shrink your image by a great extent, in those cases you will be little stuck with this resizing information. So in that case, either you take reference from the literature, or you go ahead with some hidden trials that will ensure you accurate performance of your model. So most of the time it is better to go ahead with the literature, try to see most majority of things. Some of the typical settings that we apply for images, that may be between 640 to 1280, especially when you are talking about YOLO v9. So in that case, 640 to 1280 pixels are the longest standing dimensions that majority of people have used till now. But still, how much resolution you are trying to preserve, and what is the optimal level for your kind of images that you are getting from the field, that will have little bit variation in the outcome.
Before we end this session, I would request everyone to turn on their cameras. Everyone, please switch on your Thank you all.
Yeah, there is a break, ma'am.
Yes, there is break and next session will begin at 6.
Okay, fine, thank you. So we can leave this link.
Yes, you all can leave and join next session at 6.
No, no, no. This link will remain same, sir. You can join.
Okay, okay. Thank you.
Thank you very much, ma'am. We will meet tomorrow, ma'am.
Sure, sir.
Jagrati,
Thank you
ma'am.
so much.